To everyone. So today I am starting optical instrument. Okay, so at first we have to know what is our eye. Our eye is just a natural lens. Okay, now first question is that how much long distance you can see in the normal eye. The answer is what? Infinity, because you can see stars, you can see sun, okay, in the naked eye. So see here, so they are very long distance from us, so you can see these things in normal eye. Okay, so the far point, this is known as the far point. How long distance we can see, it is called the far point. So far point for a normal man is what? Infinity. Okay, so far point is what? Infinity. Far point for normal person, I mean who has good at eyesight, so this is equal to your infinity. Okay, but if the object is very close to our eye, at that time what is happening, right? What is the near point? Near point means what is the minimum distance we can see in our naked eye? Okay, so what is the minimum distance we can see? So that is what, that minimum distance is known as least distance of distinct visions. Distinct vision, and this is equal to your what? 25 centimeter. So the question is that, suppose if you see any object is less than 25 centimeter, in this situation what will be happening? Your ciliary muscle will contracts. Okay, so D is equal to least distance of distinct vision. This is equal to your 25 centimeter, and this is written as what? Capital D. Capital D is equal to 25 centimeter. Now next one is your what? Next one is your visual angle. Visual angle. Okay, so visual angle means what? The angle subtends by object at our eye. So for example, see this pen you can watch, but if it is closer to you, it is become bigger. Why? Because the visual angle increases. So what is the visual angle? So if I draw the diagram here, this is our eye, right? This is the lens, and see this is the retina, okay, where the image is formed. This is the retina and this is the lens. And suppose if I consider that this object, this is which object? This is your AB object, and this AB object makes angle how much? That is your what? Suppose if I consider this is your alpha 1. Okay, alpha 1, right? So see, this is, if this is alpha 1, then this angle must be your alpha 1. Now the same object is very near to your eye, just like this way. If I draw, suppose this AB object of same heights, right? A1, B1 I am writing. Now if it is very closer to your eye, so see here how much angle they will make. How much angle it will make? It will make, I am saying, alpha 2 angle, and this alpha 2 is greater than alpha 1, right? So previous image was what? Previous image was formed here. This is smaller size than the final. Okay, this is okay. So see what you can observe. You can observe that if AB object is near to our eye, so it will making larger visual angle. So for that reason we are watching the same object is bigger if the object is very near to our eye. Okay, so next one is what is the function of the optical instrument? Optical instrument will increase this visual angle. So this is the working of the optical instrument, that is what it will increase the visual angle. So now next we have to understand what is the magnifying power. What is the magnifying power? The purpose of telescope and microscope is what? The purpose of microscope and telescope is what? Increase the visual angle. So its power is measured by magnifying power. So what is the magnifying power? So magnifying power, this is the topics. This magnifying power is denoted by M, and M means what? That is visual angle subtended by image formed by optical instrument at eye, and this is one, and name second one is visual angle subtended by object okay, at unaided eye. So this ratio is known as magnifying power. So in all optical instrument we will measure the magnifying power. So we will discuss in our syllabus, that is what? Simple microscope, compound microscope, as well as astronomical telescope, and we have to find out this magnifying power. Okay, so this is the magnifying power, and see, so let's understand this magnifying power. So suppose if I consider an object AB you want to watch through the optical instrument. Suppose if you consider this is the any optical instrument, if I consider this is the optical instrument, like microscope, optical instrument, right? And if you watch through this optical instrument, then optical instrument form the image of this object. Suppose the image of the object is formed at this point. Okay, this point, this is what? A1, B1. Okay, and what is the angle it makes? This image is making how much angle at our eye? So see, this is beta angle. Normally this eye is very close to this optical instrument, so this is beta. So this is one case. Now I am considering this image is formed at a least distance of distinct vision, I mean at capital D distance. Now in the same place, if you keep the object here I am drawing. So see, if the object AB, this is the object AB is placed at the least distance of distinct vision from our eye, then this object is making how much angle? That is alpha, right? So see, what is it? It's saying visual angle subtended by image formed by optical instrument at eye. So this optical instrument, okay, formed through this optical instrument, this image formed how much angle at our eye? This image is formed how much angle at our eye? That is beta. So I am writing here beta divided by, if I consider only this object without optical instrument, then this object is formed how much angle? Alpha. So this beta by alpha is known as magnifying power. Okay, so this is the just concept of the magnifying power. Okay, simple microscope and its magnifying power. Different optical instrument, we will read microscope. So simple microscope. What is the simple microscope? So this simple microscope is nothing but just a convex lens. So see here, if you keep this convex lens, okay, within its focal length, then it becomes what? It becomes, the image will become what? Bigger, right? So this is the simple microscope. Only one convex lens is used here. So see here we have to find out the magnifying power. So see here, so that means what? This is the convex lens. Here I am drawing, this is the convex lens, okay, and this is the optical center, this is the focus, first focus, and if we keep the object AB here, right? So then if I draw the ray diagram, so one ray is passing through, one second, if you draw the ray diagram, so see, one ray is incident parallel to the principal axis, and after pass refractions it will passing through the focus, right? So this is what, this is the focus, second focus, and next one is what? Next one is if one ray is incident on optical center, then it will be what? Just go to straight, right? So then if you extend these two rays, then see here, if you extend these two rays, just here I am drawing, if you extend these two rays, they will meet a particular point, right? They will meet a particular point like this. So this is, and see, this is your what? This is your image you have got, and this image is your B1 A1, right? So now very important things is that if this image is your A1 B1, now what is the magnifying power? Now this lens is very close to our eye, so here if I very close to our eye, okay, this lens is very close to our eye, so that means what? That means this image will make angle how much? This image will make angle beta, right? And I am considering this image is formed at least distance of distinct visions. Here what is this? This image is formed at least distance of distinct, that is what, 25 centimeter, right? So see here, from here we can write, and this object distance is what? This is your object distance. Here I am writing as u, okay? Object distance is what? U. So that means what? So if I consider that what is the beta angle, so magnifying power, if you want to find out what is the magnifying power means what? M, angle subtended by image formed by optical instrument. So optical instrument formed which image? A1 B1. So it is subtending how much angle at our eye? Beta angle, right? So this is what? Beta I am writing by. If you keep, see, if our eye is here and same at the same distance, if we keep the object A1 AB, if we keep the object AB, so it will making angle how much? Alpha angle, okay? So it will making angle how much angle? That is alpha angle, okay? So beta by alpha at the same distance, if you keep the object, so the object is making angle alpha with our eye, okay? So see, beta by alpha, so we have to find out beta as well as alpha, okay? So how you can find out beta? So beta is equal to, I can write here, tan beta. Beta is very small, so tan beta can be written as beta, right? So see, beta is equal to tan beta, so tan beta is means what? If you see the triangle, which triangle? ABO. If you see the triangle ABO, so from here you are getting what? Beta. So beta is equal to what? Tan beta. And see here, this is equal to perpendicular AB by OB, right? Okay, OB. And see, here I am writing AB by OB. OB is your object distance, and object distance is equal to your what? U, and U will be what? Negative, because incident ray is this direction, so you are measuring here, this is your negative. Here I am right. Okay, now same way, if we consider the triangle ABE, if we consider the triangle ABE, so see here, alpha is equal to tan alpha is equal to what? Perpendicular AB by what? EB, right? Same way, EB is equal to how much distance? This is equal to your capital D distance. Capital D is the distance, so that is equal to AB divided by capital D, and same way this will be your minus, right? So see, if you consider this one, okay, if you consider, because if we consider the sign convention, so this is your incident ray is this direction, you are measuring with respect to I, so this is your also minus, so beta is equal to your AB by minus U, and same way this is equal to your AB divided by minus capital D. So see, it will become what? Capital D by U. This is your equation number 1 I am writing here. Okay, this is your equation number 1. So magnifying power is equal to D divided by U. So you have to find out this magnifying power. U is unknown, so you have to convert in terms of focal length, because focal length I am considering here small f. So how you can get this focal length? So normally if I apply the length formula, that is equal to 1 by V minus 1 by U is equal to 1 by F. So V means what? Final image is found where? At capital D distance. You see this first diagram. So see, here I am writing 1 by this one is equal to minus capital D, right? Because this is the virtual image, minus U is also negative, because incident ray is this direction, so you are measuring with respect to optical center, this is equal to your minus, and same way this is equal to your F, right? So this is equal to your what? This is equal to your minus, giving you minus 1 by D plus 1 by U is equal to 1 by F, right? So same way, 1 by U is equal to what? 1 by U is equal to, that is equal to 1 by F plus 1 by D, right? This is your value of 1 by U. Now here I am writing, from here I am writing, this is equal to 1 by U is equal to 1 by F plus D. So both sides if I multiply with D, this is your giving you D by U is equal to D by F plus D by D. So D by D means 1 plus D by F. So D by U, it is your magnifying power. This giving you 1 plus D by F. So your magnifying power M is giving you T by U, and you have find out that D by U is equal to 1 plus D by F. Okay, so this is the magnifying power of simple microscope if image is formed at least distance of distinct visions. Okay.